Hey everybody, Justin Sparks from Inside the Polygon, 12:34 Eastern Daylight Time, and taking a look and actually going to just share with you what it looks like when we do a severe weather forecast for other parts of the country. Right now we're focusing in on the potential for significant or strong tornadoes across northern Texas and southwestern Oklahoma. So up front we have right now is the current radar satellite and basically graphical representation on the current radar screen. So right here we have Texas, Oklahoma, and New Mexico. A complex of thunderstorms, non-severe thunderstorms, are currently moving to the north across the northern portion of Texas. Those are not going to be the prime event for today. We have a basically a stationary warm front, a trough or a dry line that's existing here, and we can see that kind of correlating with visible satellite, which is going to come into play later on for us today. Real quick, while we look here from the Storm Prediction Center, this is the highest risk of tornadoes outlined by the SPC in their latest outlook. And we're going to look at kind of some of the technical data that goes with that and talk about what the ingredients are for that. So here's the official SPC website. If you're interested in fact-checking the work we do, this is the SPC, www.spc.noaa.gov. It's a great resource for getting watches, warnings, and forecast information if you're interested in looking at that. So one of the things we want to look at is what is our dew point spread on any severe weather day. And we'll bring this back to the beginning right now. The higher the dew points, the more the atmosphere is going to be capable of doing things. We'll play this forward through time here, and we're going to highlight on a couple of things here. We start to see this is the higher risk area. And by early this afternoon or middle of the afternoon into the early evening hours, we're going to see dew points are going to be surging up through moisture that's coming in from the Gulf and interjecting itself into this environment with this trough that's going to exist basically out here. You can kind of see it outlined. And then the frontal system that we saw earlier. We kind of see it here when we do it in comparison with dew points. And as we move times through here, you'll actually see as storms accelerate, there's going to be a line of thunderstorms that develops out in this area and then race off here. And it's actually really dramatic looking on here as the storms start to move. So this is kind of the animation. We'll see the moisture peak up into our risk area, and then we'll see a line of storms develop and shoot off there. Kind of a neat thing to see on the dew point scale. So we look at the significant tornado parameter, or where are conditions most favorable for tornadoes. Anything above a 1.0 translates at risk. So basically any of our blue colors moving forward. Now there's a lot of factors that go with that, but essentially if you're going to say what do we need to have a tornado, it's 1.0 or greater. We start getting into our target area and we start to see some of these things peak up here, and then we'll start to see by the 9 o'clock forecast hour 21Z, which is Zulu time here, and we look at environmental sounding, and I think you're going to see, assuming no changes and I got everything right, we're going to see a pretty particularly dangerous situation tornado risk for this area. So atmospherically, everything looks good for convection. The level of free convection, everything looks good. Cape, 18, 19, there's not a lot of inhibition. And then we look at what are our soundings. Are there supercell soundings that match? Yeah, there's a lot, and there's hail. So tornado and hail risk is going to exist right inside of our risk area here at around 21Z, which is consistent with which the SPC forecasts has demonstrated, so forth. We'll actually play this out here. It just exists for a short period of time, a couple of hours, and then we see a primary thunderstorm. If you look, this matches pretty closely what we saw with our dew point models, and that's all kind of correlating data. So we come over here, let's play the simulated radar. This is consistent with what we're seeing. This is 1 hour old. I apologize. Let's go back to here. This is going to be 1 hour old at this point as soon as this recycles here. And we'll see this is the area of thunderstorms that we saw on the radar here. If we flip back to the radar, everything's matching up well. Right at the same point, everything is what we're looking for. And that's one of the things we look for is consistency in data. So we start playing this forward here. We talked about the hour 9 mark. Thunderstorms will start to develop and start to move to the south. By the point in which we get to is the environment's most favorable for tornadoes, there are in fact large thunderstorms in the area. You can have a really beautiful environment. If you don't have thunderstorms in the area, it doesn't mean anything. If we play it out from here, we'll see an area of thunderstorm complex like we talked about, and it's going to race across central Texas and off to the east. So right now we look at there is a significant tornado risk in kind of a narrow area up here in southwest Oklahoma and north central Texas, and then we have a hail threat and a marginal tornado risk across. So please, if you live out in the Texas area or southwest Oklahoma and you have points or interests out there, please encourage them to follow local media, the National Weather Service, their local forecast office, and local media to get warnings. So it could be an interesting evening out there, and we'll be here at Inside the Polygon to keep up with what's going on. Thanks for stopping by.